All right, so thank you, everybody. We might get started now. Welcome to the Australian Eggs Traceability in the Egg Industry Traceability Showcase. This is the second webinar that we've put together as part of this project. So welcome to those attending their second and to those who are coming and meeting with us for the first time. My name's Sam Cox from Cox Inall Dentsu. We are partnering with Australian Eggs on this traceability project as we work together to build the industry's awareness, knowledge, capability and capacity to further traceability within the egg industry. We've got a really exciting lineup of speakers for today's traceability showcase. They're all going to run you through some different examples of traceability and the benefits of traceability, both within the egg industry and then also some examples of outside the Australian egg industry to showcase ways that traceability can help you in your business. Some quick housekeeping. So you'll notice that you've all been muted and that your cameras are off. So if you do have any questions throughout the webinar, just pop them in the chat and we'll get to them at the end. So just on that, we do have 3 speakers today. Rather than doing a Q&A after each speaker, please hold those questions. Either pop them in the chat or pop them in the chat at the very end and we'll go through them in a bit of a Q&A at the end. Finally, this session is being recorded, so we will be sharing the webinar recording around through Australian Eggs channels at the end following the webinar. So why are we here? So as I said at the start of the call, Australian Eggs is running a project to progress the adoption of traceability within the egg industry and then position the industry for further development and extension of traceability systems. For those of you who've been paying attention to Australian Eggs channels, we've recently launched Egg Trace, which is the industry developed traceability tool. But we know that no 2 egg farms are the same. Every egg farm's different, and so will the perspectives of traceability. So rather than just sharing tools that we've developed ourselves, we want to make sure that we're also showcasing the ways that other industries and other egg farmers are looking at traceability and how they're helping them achieve traceability outcomes. So I'll just quickly introduce you to today's speakers and then we'll get started. So we've got Jessica Fernley joining us from the New South Wales Department of Primary Industries. So she's led a project recently on how cherry growers are implementing traceability to be able to track cherries through the supply chain. A lot of crossover with the egg industry there. We've also got Catherine Campbell joining us from Source Certain. She's going to be talking about how using provenance science can facilitate transparent and safe supply chains for various different industries. And then we've got Daniel Ramp from the UTS, from the University of Technology, Sydney, joining us. He's talking about how a specific project within the egg industry and how egg differentiation and traceability can occur in real time using artificial intelligence. So a very diverse range of speakers and looking forward to get started. So with that, I might just hand over to our first speaker, Jess from the DPI, to start talking about what she's done within the cherry industry.
Thanks, Sam. It's just saying I can't start screen sharing while you're sharing. Perfect. Thank you. Okay, so thank you so much for inviting me on. I'm really excited to talk to you today about standard-based traceability systems for horticulture industries. And this is around a project that we have just recently completed. I think there's a lot of takeaway messages for the Australian egg industry as well, and some different hints and tips that you might be able to pick up when you're looking for a traceability system for your own farm. So before I get started, I just wanted to acknowledge that I stand on a country which always was and always will be Aboriginal land, and I'd like to acknowledge the traditional custodians on the lands and waters on which we meet today and show our respect to elders past, present and emerging. And just to note that the New South Wales Department of Regional New South Wales is committed to providing places in which Aboriginal people are included socially, culturally and economically. So the horticulture industry in general is faced with a number of different problems or challenges, as we like to say. And one of the main key problems that we are grappling with at the moment is that there's currently no property identification for plant industries. So unlike the livestock industry, who have the NLIS system, or the National Livestock Identification System, when a biosecurity incursion happens, or we have an emergency management scenario such as a flood or bushfire, regulatory officers have to run around and ad hocly find property, or we rely on industry knowledge, but sometimes we can miss out on properties that are in the firing line, or that are at risk of biosecurity incursion. So that was one challenge that we had. So we want to have a look at identifying properties. The second challenge that we were having is that there are numerous traceability systems available. And I would assume that a lot of you have heard of different traceability systems, whether that's on farm or throughout your supply chain, but they all rely on different data requirements. So this means that our growers in the horticulture industry might have their own traceability system on farm. But then it might change to a different traceability system for the supply chain, and then the retailer might have a different traceability system again. So growers have told me that once their product leaves the farm, they have no visibility over where it goes, where it ends up, who consumes it at the end. So this was one of the challenges that we want to try and capture in this project. And I'm not quite privy to how the egg industry works around this, but we have different protocol markets, particularly in the cherry industry, where if we want to supply export markets such as China or Vietnam, we have to have certain endpoint treatments that eradicate certain pests and diseases. To certify that we've done these endpoint treatments, we actually have to have a paper certificate that is stuck onto the side of our pallets. And this has to manually follow the pallet wherever it goes. So if we're able to digitize this, we would save people a lot of heartache and stress when their certificate is lost from the pallet, or when they're trying to obtain that certificate in a high stress situation, like in the middle of cherry packing. So the 6 of our project partners, it was quite a large project, involved many stakeholders. We put our heads together and tried to design a traceability system that could not only be used by the grower, the supply chain, the retailer, and the consumer and government, but we were able to trace from property to consumer back and forward, and understand where property was sitting in the supply chain using data standards. So that's really important, having that interoperability of all those different stakeholders. So the objective of the project was that properties in the horticulture supply chain could be identified, product tracked and traced to support biosecurity and food safety management. And our outcomes for this was using data standards. So for our particular project, we used GS1 data standards to identify properties in the horticulture supply chain. And we wanted to prove that these data standards could support efficient emergency response and supply chain logistics. And that includes all required data for market access. And then as a value add, we wanted to identify pain points in the supply chain, which could be used to minimize waste and then improve product quality for consumers at the end. So we had a pretty simple project. We wanted to look at 2 different commodities. We wanted to look at a really perishable item such as cherry, which doesn't spend long from packing to consumption, sorry. And then we also wanted to look at a product that might sit in supply chains for a little bit longer, just in the nature of potato being such a staple commodity. So we looked at potato into the New South Wales market. So it was packed in New South Wales, tracked through New South Wales, and then consumed in New South Wales. And then for cherry, we did the same in the New South Wales market, but we also looked at South Australia to examine that interstate market access component with the digital certification. And that's really important for cherries because in New South Wales, we're compromised by Queensland fruit fly. And in South Australia, they don't have Queensland fruit fly. So they really don't want our fruit, if it was infested, to get into South Australia. So that was a really good pilot for us to see if we could prove fruit fly freedom using this method. So the way that we were able to identify the traceability system was that we allocated global location numbers. So that was the GS1 data standards. So this GLN is able to be applied on the label. So you can see in that top right-hand corner there, sorry, all of our labels have this little QR code. And within that QR code, we've actually encrypted this global location number. So the way I kind of envision it is the global location number is attached to that clamshell, and it kind of pings off at certain points along the supply chain. So you're able to interrogate it and where it has been picked up in the supply chain and how long it's spent at certain locations. So that little QR code is actually called a digital link QR code, so the GS1 digital link, and it has many different services that it can provide. Not only can it provide traceability data, but I'll show you in the next couple of slides the value add to the grower of what this digital link QR code can do. And that all surrounds a user experience. So the digital link QR code was able to allow us to develop a user experience, which I'll show you in the next slide. To prove that our barcodes were able to prove a traceability system, we also put sensors within the pallets, and that was able to show us different temperatures and light interference as well. And we also were able to upload a digital certification, a digital certificate to that QR code as well, to show that we could digitally put our protocol endpoint treatment certificates into that QR code. So the key results that we had from our project was that we had 2 successful end-to-end traceability pilots. So we were able to identify and isolate product in under 60 seconds. And that was using a combination of the Fresh Chain dashboard, which was our traceability system, and those data standards, those GS1 data standards that we could use across the supply chain. We were able to reach the consumer in the event of a recall. So in that top left-hand corner, we were able to actually send out a message directly to the consumer. And when they scanned our product at the end, they were able to get this message to say, please don't consume this product and return to Woolworths. We were able to demonstrate the benefits of using GS1 data standards, and we created an interesting and engaging platform for consumers at the end. And this platform at the end was able to provide data insights to the grower. So when we talked to the grower about this, they said, oh, well and good that I can track my product, but what's in it for me? And this part around interacting with the consumer was one of the main parts that they liked about this project. So I just want you to, if you've got your phone next to you, scan this QR code and you can see what user experience we attached to our products. So not only we had the traceability system that sat within this QR code that government and retailers could interrogate, but when the consumer was able to scan at the end when they're consuming the product, they're able to see things like when it was packed, recipes about the product, how to store the product, and then they're also able to rate the product. And that was the value add for the consumer, for the grower. They were able to get real-time feedback directly from their consumer about what they thought about their product. And so for the egg industry, there could be all sorts of things that you guys put on there, such as if you were free range versus caged, or if you were in a certain part of the world that has really nice clean air for your chickens. Maybe you have some really fantastic recipes that you want to put on there to encourage people. It's just a really great platform to educate and encourage consumption of your product. So the main benefits to industry that we discovered on in our pilot was that we were able to have an integrated digital traceability system. So now growers have insight across the supply chain. They don't lose sight of their product after it leaves the farm gate, because all the data is now able to be popped onto any system that they had. We were able to trace products forward and backwards in the supply chain, and we had quick identification of property and assets, which minimizes loss to the grower. So we were able to isolate product down to the batch. So in case of a recall, we could continue supply with all other batches except for one batch, which I've heard will worse. It will save them countless amounts of money and protect brands as well, which is really exciting. The ability to interact with consumer assures of food safety, provenance, and authenticity, and improves consumer confidence. We reduce the economic damage to growers and industries, and we have the ability to open new exports by creating clearer supply chain visibility and quickly accurately identifying the origin of a product. With all of this, connecting growers with the consumers. So I'm more than happy to for anyone to reach out and contact me about the project. And I've also got GS1 and our traceability systems contact details there as well if you're interested. So thank you.
Thank you very much for that, Jess. So next up we have Catherine Campbell from Source Certain, who's going to talk about her company and the way that their technology is able to, assist with the safe food supply chain. So take it away, Catherine.
Thanks, Sam. Hi, I'm Catherine Campbell. I'm the Chief Commercial Officer for Source Certain. I guess here to talk to you a wee bit about our technology and how we sort of play a role in terms of supply chain integrity and transparency and contributing to safe food supply chain. So I'll just run through a wee bit about who we are and what we do, and then I've got a couple of I guess slides around case studies across some different industries. Okay, so who we are. So our vision is to build a better world through accessible and transformative science. Our scientists are regarded as leaders in their field, and we've worked on a number of complex scientific investigations globally over the last 10 years, and they range from everything to do with gold and diamonds, right through to seafood and critical minerals. We're actively involved in research, and collectively amongst all our scientists on board, we have over 300 peer-reviewed publications. So what we like to say is we're really proud of the fact that we've developed our own technology in Australia. We own our own laboratories, and our scientists are leaders in their field and are available to work with customers too when we have issues or certain technical projects that require some additional thought and curiosity around them. I guess what better way to talk about provenance science than to give you a wee bit of provenance history on the technology itself. It's a lovely story. The TSW trace is what our patent technology is named, and there's a wee bit of history in there. The T and the S and the W are the beginning letters of all the last names of the people involved in developing that technology. The S stands for Scadding, and Cameron Scadding is actually the guy in that picture there on the left-hand side. He's our MD and founder, and he is a forensic and analytical chemist. The W stands for Watling, which is Dr. John Watling. He is our chief scientific officer, and he's been, I guess, an analytical chemist since the early 1970s. So he's got over 50 years of experience in consulting sort of law enforcement globally. So there's a raft of really great experience sitting behind us salespeople as we come out here and sell our technology. So TSW Trace is the name of the technology we use. It looks at markers that are already present in the product to verify the origin. So where a product is grown, it'll pull markers or I guess nutrients from the ground. So if it's a plant or if it's an animal, what it's eating and where it's feeding, to develop its own unique set of markers and chemical elements. And that provenance solution is effective at verifying the origin before and after processing. We do inherently run into different, I guess, challenges when we work with different products where there's processing involved or movement. But generally, once we sit down and we understand the product and the process, we can identify where we need to look and what we need to look at. So we verify the product of origin. Consumers, I guess, are in a world where there's so much information and so many claims being made by producers. So they want to know now more than ever who they can trust. And I guess that's where we come into the program. So as I said before, the food products in particular, they'll pull natural markers that we analyse using this TSW trace. And that will often be water, soil dependent, feed dependent. The combinations of all of those different markers create what we would call a reference fingerprint. So I guess like humans with DNA, this is like food and natural products with chemical markers. So the technology is so specific that we can tell the points of origin apart, even if they are relatively close together. For example, we work with a cherry producer now out of Tasmania, and even though there's the same variety on 4 different blocks, each of those blocks has a completely different chemical fingerprint. So it gives us a lot of sensitivity in that space. Once we develop those reference fingerprints, we then work with customers to sample across and throughout their supply chain, which means that the product that leaves the farm gate or the paddock or wherever is the exact same product that ends up at the end. And that's why we say, look, we're not traceability, we're certainly provenance, which is slightly different. So we're here to sort of work with people in conjunction with traceability to sort of verify at each of those traceability steps. Our service is applicable, as I said, across many industries. We're working, for example, with critical and strategic minerals. Now more than ever, as we're working with renewable energy. Gold and diamonds, we work significantly with lab-grown diamonds, creating fingerprints at all of the manufacturing sites and verifying back to source. And we go through to horticulture and meat as well. We have been involved from a forensic level in many investigations globally, and gold is one of those. So we work with law enforcement around tracing stolen gold back to the mines of origin. So it's certainly an interesting space to be in. If we move into our first case study, we work intensively with the Australian prawn industry. And I guess some people might have thought as we go through this, you know, is it something that is an industry project or is it a customer individual project? And the answer is it can be either. It just depends on the situation, the product, and where the risks are. So we were fortunate to work with the Australian prawn industry. It was a collaborative project that was launched back in 2019 and has now since been so effective, the national program's been renewed to 2025. We work with Curtin University, the FRDC, and obviously the Australian Council of Prawn Fisheries. And with all of that buy-in, we're able to map every single farm. So whether it was the prawn farm or wild caught, and the wild caught has its own challenges, but it is still possible in terms of areas of provenance. And then what we've done after we built that reference database with all of those industry players, we then engaged in some covert sampling, which we do ourselves through high-risk seasons. So we look at generally Easter and Christmas, where we go out and we sample covertly within industry across Australia, everything that's labelled Australian prawns and with regions, and then we can report back. And we saw quite a significant decrease, I guess, in potential substitution issues throughout that supply chain. So I guess from a food safety standpoint, it's also helpful if there are any issues from a biosecurity level, then it allows us to sort of trace back and verify origin to make sure, you know, anything from specific areas of interest may be excluded from that market instead of sort of, I guess, a blanket applying a ban to the whole market. So it's there entirely to protect the Australian prawn brand, and we certainly see the effects of that working relatively well. Another study was more customer centric. So this is the Bravo apples. This is a licensed product out of WA. And we worked with WA Farm Direct to map all the licensed growers now throughout Australia. Our first study just focused on WA as a pilot and proof of concept. So we map all those orchards out. And again, the technology is so specific that the sampling process to build that database is crucial. So we go out and make sure that each block is sampled from all the perimeters. And if it's multiple blocks, then we do multiple blocks for those farms and licensed producers. So now we have completed the reference database build for the full 81 licensed orchards across Australia. Each of those has a completely unique fingerprint. And now we go out and we're just undertaking our second round of covert sampling. And I guess from a grower standpoint and a customer standpoint, this means that A, those growers are supplying who they're supposed to be supplying, and B, there's no rogue licensed growers out there that these guys don't know about, because at the end of the day, they have some protection of brand, and that means, you know, fruit getting to how it should get, size, quality, and all of that. We also did have a part to play in some egg traceability work around the provenance, and we were able to certainly go back to even the same farms, discriminating between sheds on each farm and free range versus barn laid. And it was really, really interesting when you had chickens progressing from sheds even to free range, how little time it took for the chemical nature of the product to be able to be differentiated. So it's absolutely possible, and we've done this on eggs, and we spent a fair bit of time in the early stages figuring out how we need to sample that. Obviously, you've got shell, you've got egg white, and you've got yolk. So there was a lot of R&D work in the background that went into sort of getting the sample prep right to be able to see this. We measure a raft of different elements, and on here, obviously, you can see some overlap around these two, but this is just a 2D, I guess, a flat picture. If you look on the side here, when you spin these, because we're analysing a raft of different elements, we tend to snapshot a graph so we can show you sort of the differential that we're seeing on one or two different elements. But bear in mind too that we're measuring pretty much the entire periodic table. So there's, and certainly paying particular attention to about 65 or so trace elements of importance. So whilst that might look quite similar there, I can assure you when you add another 62 or 63 measurements, they become quite different, differential quite clearly. So yeah, so this is featured in the GS1 report, published back in 2020. It's called the Australian Eggs Traceability Technology Desktop Review. So we were certainly able to achieve that geographical discrimination there. I guess that's the end of it from my side. So just a couple of take-home points. It's sort of like, why would you do this from an industry standpoint or from a business standpoint? And I guess a lot of it's around protecting your brand and protecting your product, whether it's licensing that you're protecting or a food safety element. There's certainly a role to play here for us, and we're happy to help and have discussions on a case-by-case basis. If there are any questions, don't hesitate in reaching out. Thank you.
Thanks very much, Catherine. So if you can just stop sharing. So our next speaker, Daniel, can take over. So Daniel Ramp is our next speaker from the University of Technology, Sydney. He's going to be taking another deep dive into egg differentiation traceability with respect to a current project that Daniel and his team are working on within the egg industry for Australian eggs. So I'll hand over to you now, Daniel.
Thanks, Sam, and some really great talks to follow on from, and in particular from the work that both Jess and the traceability aspects and Catherine with that sort of the provenance aspects. I think the work that we've been doing, I think, will really cement the merit of the possibilities for the Australian egg industry. Our background is not in eggs, but typically in agriculture, biodiversity, and environmental sensing. So we look at a whole range of ways that we can value add to in both in agriculture, but also in conservation. I think the really interesting aspect of with eggs, and this was highlighted by Jess, is that when we've got traceability, the traceability systems that are put in place where there are, you know, attaching QR codes and so forth is really important. But what happens when those labels are lost? What happens when there's some unknown eggs, or if you just want to verify that they are what they say they are? You need the kinds of solutions like Catherine was talking about from Source Certain to enable you to do those. So really the foundation, if we're looking for a solution, as Catherine was talking about, the foundations for this kind of tracing is based in the chemistry that those products, different kinds of agricultural products take on. And this comes from the parent material and water. So anything that is in the soil and in the water will have these different amounts of elements. And that's the start of how we work out the pathways into eggs. So when we think about what happens with that parent material in the water, it comes up from the soil and the water, and then it goes up into the food chain. And so depending, the old adage of you are what you eat, for chickens, if they're fed something that comes as a product that's purchased, then it's still going to be derived from different elements of chemicals and the locations where those came from. Likewise, if it's a free-range hen, then she's going to be feeding on things that are in the pasture, and that could be a whole range of different things. And that helps to create a signal that we can then trace. So there are different kinds of ways that we can do this. So there are really large devices that can trace chemical signatures, such as the Australian synchrotron. Obviously, they're not very portable and then not very useful, and also incredibly expensive. These kinds of devices, so there are ways of looking at the isotopic signatures of certain chemicals, elements within the sample. But X-ray fluorescence is another really good non-destructive way of getting a signature. So the synchrotron does that. There are lab-based kits that enable you to do that, such as ICP-MS or mass spectroscopy. Then there's also portable. And this is where we became interested because we do a lot of work in the field. We know that some of the costs for sampling the chemical signatures within a sample are quite high. And you really need something that's going to be flexible and able to be done, hopefully in real time. So these portable X-ray devices are not as powerful as the synchrotron or ICP-MS, but they're getting extremely good. And the signatures that the number of elements that they sample can be quite high as well. So what we've been doing is looking to exploit the ability of these portable X-ray fluorescence machines to be used for tracing eggs and determining egg provenance. So, and I think as Catherine was explaining, what we have here is if we can get a signal from an egg, we then want to be able to extract that data. So we can scan an egg, and we can do that in real time. Hopefully it's inexpensive, and it doesn't really require someone with a PhD to be able to operate. That's really important if we're going to be thinking about, can we actually use this on farm as part of some kind of auditing process? We then need mechanisms to transmit that data, whether it's via Wi-Fi or mobile devices. We need to be able to process it. So that can happen either on the device or it can happen in the cloud. We need some kind of analytic process to happen to determine what something is, where it came from. And then we need mechanisms to be able to inform users, so producers, part of the supply chain. And ultimately, what we want to be able to do is to use this to enable some kind of action to be taken. So that action could be auditing, it could be certification. So for example, if you've got a free range product, for example, that's quite different from something else, then you want to be able to certify that it was actually produced under those conditions and that it is that egg did come from you, then this is the kind of tool that you might need. It's also possible to use this kind of information both in education and also policy development. So as was mentioned, the underlying way that we work is to create reference libraries. So what these are knowledge of the kinds of signals and signatures that we would expect from eggs coming from different regions, different producers, or under different kind of farming conditions. Once we have a reference library, we can then use classification models or different kinds of analysis to determine if we have an unknown egg, which category does it belong to? So at UTS, what we've been doing is asking the question about whether or not, if we have different eggs, where do they come from, and how can we use different kinds of analytics to tell us that. Now, one of the great advances in the last 10 years has been in artificial intelligence. It sounds fancy. It essentially just means we have lots of data, we throw it into models, it becomes a little bit of a black box, but it tells us what we need to know, and it's reliable. So what we've been doing is playing around with building all of the necessary coding and so forth, and doing the scanning of the eggs to see whether or not this can actually work. So before I tell you exactly what we've done with the eggs, I wanted to show you that we've actually got a bit of evidence to say that we have actually been able to show that this can work in some different circumstances. So this is some work that we did in the illegal wildlife trade. And in this example, we had echidnas. And there are some breeders of echidnas that were claiming that they were breeding lots of echidnas to then sell. But echidna breeding is incredibly difficult. So there wasn't a lot of confidence that they were actually doing what they were saying they were doing. There was suspicion that they were taking them from the wild. So what we did is we scanned the quills on those echidnas to see whether or not we could tell the difference between a captive echidna eating a captive diet and a wild echidna that's eating a wild diet. And the great thing about those quills is that they last a long time. And so effectively what you've got is you've got a situation where, for example, here we've got an element of calcium. We can see that typically for wild quills, the values of the concentrations of calcium are higher than in captive quills. We run those through our models, and then we can work out if we've got an echidna, we can sample its quill, doesn't harm the echidna, doesn't cost anything, and we can tell whether or not that echidna came from captivity or was taken from the wild. Likewise, we were interested in the movement of water birds. Now, water birds are amazing because most of them travel right across the country. So we had this is a project in collaboration with University of New South Wales and ANSTO, and we had a citizen science project where we collected feathers all around the country. We encouraged people to send us feathers of water birds from where they were found. And what we then did is scan those feathers, and were able to build some models to tell us where those feathers might have been grown. Because even if you find the feather in Perth, for example, over here, what we found is that some of those feathers were actually grown in Queensland. And that enables us to work out that, in this case, it was a pelican, that those pelicans had been flying from Queensland to Perth. Now, the only other way to do that would have been to capture a pelican, either put a ring on it, and then somebody might have seen it in Perth, or else you put a GPS tracker on that bird. But those things are quite expensive. And this was basically an almost free way of tracing these animals, and multiple at volume. So what were we proposing for eggs? This is just a pilot study. But there's no point doing a pilot study if you don't have an idea that it's going to actually benefit the industry. So we developed a method of testing that we will do. And if that's successful, then there's the possibility of expanding. What we've done is gone and collected a whole range of eggs from farm gate, as well as from supermarkets of different kinds of producers, both free range and cage. We've scanned them using the portable XRF. Now, we know that we could have scanned them also with other kinds of devices, but we wanted to make sure that our signatures were robust to any kind of stakeholder in the supply chain wanting to get involved. So whether that's the supermarkets to do auditing, or whether that's a farmer, we wanted to make sure that it was accessible. So we built our models and we analysed our results. So this is an example of what we've done in the lab. Now, obviously, here you can see that the actual device has been put into a stand. That just makes it easier, particularly when you're in a lab environment. But you could also just hold that device stable. As long as you can hold it still for about 60 seconds, that's fine. And then we basically run it through our modeling process. We can have different kinds of models that we put out. We can have ones that tell us about something about the elements. So this might be useful for looking at things like nutrition or the kinds of conditions that those eggs were raised in. We can use it for prediction. So if we take an unknown egg, can we tell which producer it came from or whether it was free range or cage? And we can actually even then create some heuristic libraries. So these are very sort of simple yes, no kinds of things. So these models, these predictive models, are very, very complex and not necessarily understandable by scientists, let alone farmers. So what we also want to do is to make sure that we can pull out of these models very simple methods of saying if calcium is above a certain concentration, then that makes it likely to have been a certain kind of, come from a certain kind of farming practice or producer. So in terms of progress today, we've been collecting eggs from farm gates where we can be confident of production type and location. It's been quite a challenge to get cage eggs from some farm gates. So if any of you listening have some cage eggs available to scan, then we would most welcome them. But what we've done is so far we've been building models to predict whether or not they're cage free or free range, ignoring which producer they came from. And we're getting accuracies of around 74% and 71%. And we can be fairly confident in these as well. So our confidence is quite high. So these are actually very encouraging signs. We're also able to tell the difference between producers. So these eggs are all from New South Wales. Accuracy across those 21 that we've surveyed so far, where we had 60 eggs per producer, is not as good as we'd like, but there's quite a big variety there. So some of those we had accuracy of 90%, where we could be 90% confident that the eggs came from that producer, but some of them weren't that great. So these are, as far as a pilot study goes, this is quite encouraging. What we also found is that when there are certain elements that were very important in distinguishing between producers, whether or not, and these are sort of free range producers versus cage. And so you can see that these are the elements that were significantly different between producers. So you can start to see that there might be some interesting opportunities, not only from a modeling point of view, can we determine provenance and traceability, but also in terms of what kinds of nutritional differences might be happening, and that might then lead to better product. So from the point of view of our work here, it's very encouraging. So far, our focus on is differentiation of production type, but other problems of traceability and provenance can also be addressed. And really our goal here is to just see what's possible, to try and invest in a strategy that's accessible across the supply chain, to complement the kinds of QR codes that are being employed, and then to see what questions and opportunities there are within the Australian egg industry to use this kind of technology. So that's all from me.
Thank you very much, Daniel, and thank you to all our other speakers as well.